Hello, everybody. I'm Rob from Milan, Italy, and today I'm going to show you some alternatives to run workloads that are long running by design on Azure on Platform as a Service. Okay, I am a fan of Platform as a Service since the beginning, so I'm using Azure since the beginning of the platform. And initially, there was just a service called Cloud Services and the storage. Then came the SQL database, not as it is today, of course, and so on. Now, Azure is a comprehensive set of tools and platform as a service products that are really, really engaging with the developers. Okay, so we are going to show some of them thanks to the sponsor. And a brief introduction. Okay, just do you see my screen? Yeah, okay. A brief introduction of the workloads that I want to talk about to you today. Okay, I think there are mainly two kind of workloads. Something that I can call jobs that are triggered. Okay, triggered by something. Okay, triggered by a skill, triggered by a webhook, triggered by an event. Okay, generally. And generally speaking, there that kind of jobs are singleton. Okay, so jobs that just runs for that specific trigger, that specific schedule. Okay, and after that, after the work is completed, it's okay. At the other side, I want to use the terms of continuous jobs. Okay, that is taken also from the web jobs platform in App Service that we'll gonna see in few minutes. Okay. And what I mean with continuous job, that kind of jobs are long-running jobs that are going to run forever. Okay, of course, forever means, for instance, get items from a queue. Okay, so when a queue has been written by someone else, okay, you just need to be there to listen to that queue. Okay, so you don't need to pull that on a hourly basis. Okay, you just need to continuous run to stay and listen for that kind of events, that kind of notification. Okay, so that kind of jobs should run continuously and should also be more than one. Okay, what I mean, if you have a million of items to the queue from a queue, okay, you probably have a job that does the job, okay, perform the task. But if you have two, for instance, or three, or 100, you will probably the queue in a faster fashion. Okay, so I want to tell you this because of the difference between trigger jobs that are usually a singleton, okay, compared to continuous jobs that are mainly scalable jobs. And I mean scalable in terms of multiple instances of that jobs in multiple machines, in multiple places. I can have an instance of a continuous job that runs in the cloud, another one that is running into my local machine, and regardless of the location, it works. Okay. So after this brief introduction, just to set up the terminology of the session, I want to briefly recap what I mean with IaaS, PaaS, and serverless. IaaS stands for Infrastructure as a Service, and you manage everything, pretty much everything of the platform itself, except the physical structure, the physical deployment. So if you have a virtual machine, for instance, you, of course, you are not managing the underlying networking stuff, the location, the rack, the server, the hard drives. Okay, you just manage the operating system, and from that point upper. Okay, in platform as a service is better because you don't see the operating system usually. Okay, otherwise it's not PaaS probably, or it's just a trade-off between yes and PaaS. But in pure PaaS, you have just the access to the location where the services are deployed. Okay, in terms of data, in terms of application. So, for instance, if you in the 90s uploaded some website on a web hosting place and you just had the FTP location where to upload your site and then it runs, okay, I would say that it was the first platform as a service we have in the world. Okay, of course now it's completely different. Okay, so platform as a service are many. We have data pass, we have web pass, and so on. And in the latest year, the term serverless raised with much importance, because I think that PaaS and serverless are pretty much the same, but serverless is just an emphasis on platform as a service that are built per consumption. Okay, so there are still PaaS platform with the visibility on your allocation or on your machines that you allocate under the hood that perform your tasks. So your in some platform as a service, you have the visibility on you pay for 20 euros per day for that kind of instance. Okay. In serverless, the emphasis is around the consumption. So you pay just for the second that you use that kind of resource. Okay. So the underlying infrastructure is the same. Serverless is platform, of course. Not always platform is serverless. Okay. Good. Let's go ahead with this quadrant. I produced this. Okay. It's resemble some other quadrants in the market, but of course it's completely done by myself, so it's kind of opinionated. Okay. What I wanted to show you on this axis, there's the ease of management. It's something like the degree of the ability, the ease of govern your what I want to say is well, let's find a word. Let's start from the scaling perspective. That is much better to say. The scaling perspective, of course, is how the degree to scale of a service. So, for instance, a virtual machine, it's the less scalable service. Why? Because if you want to scale it to 100 of machine, we just need to create that machines manually, okay, or with the scripting technologies, okay. But after that, we need to maintain them one by one, or with scripting technologies, okay, and dig some value-added services on top of that. Instead, the ease of management can be the degree of the interest we need to have on the underlying infrastructure. So what we want to see about the underlying infrastructure of the services, and if we see that kind of details, it is good or not? I think it's not, okay, because if we see those details, we can probably manage them, edit them, change some configuration, okay. So the ease of management, you can handle that as the degree of interest we have on the underlying infrastructure. In that scenario, I placed those services. It's not complete, it's just the few services that I love, okay. And in this demo, we will see Azure Batch container instances and app service with the web job part. Okay, good. Let's start with Azure Batch. Azure Batch, I wouldn't call it a real platform as a service. I think it stays in the middle between the infrastructure and platform, because the under the hood technology is something that takes the VMs, put them together, many instances together with the concept of scale set. Scale set in Azure is just a definition of a VM image to scale, to create like hundreds of instances with the same image. Okay, so it's just that technology. We are not talking about application. We are not talking about deployment. We are just talking about a VM that can be replaced as it is for hundreds of times, and this is scale set. Azure Batch adds on top of scale set some value-added services. For example, deployment feature, running feature with log shipping, with something that connects to that VM to deploy the workload and get the details and get the logs without any hassle to do that by your own. Okay. So it's something that makes the usage of scale set and VM really easier for for everyone. Okay, so let's start by looking at Azure Batch in the demo. We already created the batch account. It's just a seamless and really straightforward operation, but I created that before. I just want to mention a thing, batch. Okay. I just want to mention that if you are going to create the batch account, you will see these two options: pool allocation mode, batch or user subscription. I want to point the finger on this because if you say batch service, all the VMs that are created by your batch account are not visible into your subscription. They are completely handled by Microsoft and you don't see them. You just pay for the consumption, okay? So it resembles the serverless approach, real platform as a service approach. In a user subscription mode, the batch service will create VM in your subscription. Okay, which is the difference? From the service perspective, it's the same. Okay, the result is the same. But I really prefer this approach because I don't see any stuff, any networking stuff, scale sets, and nightmares in my subscription, and it's better from my perspective. The only difference is if we choose this mode right now, after the creation, we will have to negotiate the quota of the CPUs with Microsoft with a support ticket. So it's a matter of hours. Okay, so to start up faster, we can use this mode as it is in the demo, and VMs will be created in our subscription. I really want to mention that part because it's the way we can see Batch as a pure platform as a service without any interference with our subscription. Okay, that's good. What we want to do right now, before going into the details of Azure Batch, I just want to create a job. Okay, that is really simple in .NET Core. I really want to ask to you how many of you are using .NET Core, but unfortunately it's live event. So if you want to just post a question, I will see it live. Okay, so Azure Day. And in this really complex job, I'm joking, of course, I want to simulate a continuous, a long-running job that runs for forever. Not really forever, I just want to run it for a few minutes. So on the time you can see now, and I say, okay, while start at minute 5, so for the next 5 minutes is measure of datetime UTC now. I would say hello Azure Day. Oh, okay, so let's also make rhyme. And just to avoid an infinite loop of right line, I'm just putting a slip here. Okay, let's go ahead. Opla. Let's see if it's working. Okay, it's working, really simple. Okay, so I want to publish that binary somewhere to be used by Batch, okay, because I want to run this workload on Batch. Okay, in another session that you may find on the internet, I'm just focusing on Batch, and in this sample, this code sample, instead of being just a console write line, is something that dequeues an item from a queue to process it and take the next. Okay, that case is really better for Batch because in that case I scaled the job to hundreds of machines in Batch, and of course the queue is being consumed really faster. Okay, so if you're interested in Batch after this demo, you can find it somewhere on the internet. Okay, right now I want to deploy this stuff on Batch, and I'm gonna create a pool. Okay, a pool is just a definition of nodes. Okay, I'm call it Azure Day. I take Ubuntu from the marketplace, so canonical Ubuntu 18. I don't want to attach some other data disk that I previously configured. I can choose the instance type, and this is the point of Batch. Okay, So at the end of the session, the main takeaways of Batch are: if you want your own VM size and you want to choose, but with this kind of this many VM size that Azure provides to us, okay, you're going to use Batch. Okay, in our case, we are going to take the cheapest one. I would say 2 nodes, but I can also set up a rule, an expression that takes the number of jobs that are pulled into that pool, and based on that, it will perform something like an auto scale. Okay, I had that in production. It works, but for this demo, I prefer to say just 2 nodes and going ahead. The startup task is something that is running after the node has been powered up and before your job is running, okay, which is the ratio of this. If you start up an Ubuntu server, you won't probably have .NET Core installed, as it is in this case. So I want a startup task, and I want to say run something to install my my .NET Core. This kind of script is here. So I can take all the stuff here and put it here, but I can also publish this entire script and run it in the same place of the binary. So what I want to do right now, let's go into the Azure storage. The Azure storage is the foundation service that holds blobs, and you probably may know that. If you don't know that, please learn that, because it's the most important, one of the most important services in Azure, the foundation services. Okay, so I'm gonna create a container, and inside that I'm going to paste some stuff like the script I just showed to you, and just a few seconds, all the binaries. Oh, blah. Okay, it's not working. Wow. Good to know. Okay, perfect. Okay, the upload is not working, and this is real good news. But we can use the dry run binaries right now. So there are the same files, so .NET Core install.sh, and another job that is here in the and in this sample. I'm just telling you running and doing special stuff instead of hello Azure Day, but it's the same. Okay, so let's cancel this. I don't know if there's some network issues, but no problem. I will use this. Okay, so I want to mount this container inside the VMs that are powered up by Batch. Okay, so let's go back here. Let's go here in resource file. I will pick a storage container. I will choose this, dry run, of course, yes. And inside that, batch service will mount this container inside each VM of the pool I've been creating. Okay, so after that, a special path is available into the Linux machine in this form. Okay, so the file system will be mounted in this path. So I'm just executing this as the admin, and this is my startup task. I'm going to say OK, and the node is being creating. Okay, since in this part of the demo, I usually wait for a couple of minutes talking about the details, the under the hood details about that, because it takes about a couple of minutes to create that 2 nodes to be ready to assign some sort of jobs. Okay, in this case, since the default pool is already created, okay, so there are just 2 nodes that are idle, so ready to go. And that kind of nodes executed the same startup task. We can just use that nodes. Okay, so I can see the log of each VMs. In this case, the standard output printed the startup task results, so the installation of .NET Core runtime. so that two nodes are ready to get operation. So which is the next step? Usually batch is controlled by an application, so we can of course go here and say create a job, but the preferred approach is an application that through the REST APIs create jobs on the fly, because it's very unlikely that you are going to create your jobs here, because jobs are many. Usually you can have jobs that spawn hundreds of machines, so they usually been controlled by an application. In this case, since it's a short demo, I will create the job here, telling Azure day job. Inside the job we can have some tasks, so I'm going to select the default pool here, and inside the job I'm gonna create a task that is Azure Day Task 1. What is doing this task is calling this command line command. Okay, there are some options here. I submit the task, and in a few seconds, if a node is available into the pool that I selected, the task passed from active to running. So it's running, and each task, okay, this is just a single item, single execution object, has its own standard output. Okay, so think about to scale hundreds of tasks in these nodes, even concurrently, and each task will have its own log. It's a really powerful platform. You don't see any VMs under the hood. Everything is managed by batch. In the meantime of this demo, probably the pool has been created here. So, okay, even this one is being creating. This is starting, so the VM is not started yet, and this is the waiting for startup task. So this node is executing the startup task. So if we go here, we see that is installing the .NET Core runtime, probably, if we refresh for a minute. Okay, that doesn't matter. We already did this in the other pool, so we can go ahead and we can resume the presentation. So the next service I want to show you is the app service. I think it's one of the most, or the most interesting platform as a service toolkit suite in the cloud ecosystem. Okay, app service was born as Windows as a website, so a way to run web workloads without any hassle about VMs and so on. And now it's a comprehensive set of features to run both web and batch workloads, and under the hood, and worker workloads. Okay, so it is also cross-platform. Okay, so you can run .NET Core, .NET Full, Java, Node.js, something else. Okay, and I want to point the focus on the subset of services called web jobs. Okay, if app service is 100% of the service, the web job is just a 10% probably, or 5% of the service. Okay, so it's just a little portion of the service that permits to run long-running workloads or triggered jobs, so under the hood workloads without any UI, without any web. Okay, so let's go to show you that. I'm gonna create a web app. So excuse me, pardon for the terminology, but you needed to create this as a web app. Also, despite we are not going to publish any web asset, okay? So because the web app is the container with many features, with also the web jobs. So let's go in here. Let's say it's day 01, because I probably Azure Day is already taken. No, it's not taken. Good, I take it. Runtime stack .NET Core. It's not more core. I forgot this, but it's okay. I publish it in West Europe, where in a pool. Okay, So remind the first thing I said in the session, that in platform as a service, you often see the VM size, the tier of the service. Okay, in this case, I'm going to publish this website into this demo plan that is a topology of one VM of a specific site that is costing, I don't know, like 50 euros per month. Okay, something like that. So I'm going to publish this on that, but that should and could contain many services. So you can pool many web apps with web jobs inside a single web application plan. I would say disable, no, I don't want anything, I'm not buying anything more. Okay. In a few seconds, this web app is ready. We can publish our web workloads, but it's not what we want. We want to publish a web job. What is a web job? A web job, the good thing around web job is that there is no lock-in. So you don't need to take your console application, add some fancy SDKs or something like that. You just have your console application that uses the console. So it's really, really plain, okay? It runs on batch, it runs everywhere, okay? We build that. We have this file system, okay? We take this stuff, we zip it, okay? And inside the app service, we're going to web jobs and say, I don't know, my job is in this zip file. It's continuous and multi-instances. Okay, now let's take a look on these options. Continuous is the type. So if I select continuous, I'm telling the platform that the job should run forever. In the case it's stopping, and we know that after 5 minutes it's stopping, the platform will rerun it again. Okay, so it's a very good feature. In case it's stopping for a good reason or for a bad reason, we are telling the platform, please, this should be continuous, so start it again. It can be multi-instance or singleton. So multi-instance is the basic assumption that we made with the continuous services. If we have one, we can have many. Okay, but in case you have that exception of a continuous job that should run standalone, just one instance, because I don't know, it's cleaning stuff, so it's better to run it as a singleton, you can specify single instance. At the other side, we can have triggered web jobs. So triggered is a web job that runs just in a specific event. So the event should be a cron expression, or if not specified, it's manual. What it means, if I upload a trigger web job that is manual, we need just to press run here, it will appear after the upload, to run the job. Or better, we have a URL that we can use as a webhook to the starting point, to the entry point. So it's a common approach to have some cron jobs in complex applications. So one runs during the night, one runs now, one runs every 5 minutes. Okay, so you can schedule the jobs with a cron expression. Is very flexible, and everything is high available and high reliable. So the VMs that is executing your workload, if it fails, Azure App Service will raise another VM in seconds. So it's amazing. Okay. This is the web job. For every job, and I can have hundreds, okay? So in my production server, we have like 50, not 15, so 50 jobs in each app service, and they work like a charm. And for each one, we can have isolated logs. So just wait for a minute, no, a few seconds. I'm connecting to an application that is like a fabric application, a controlling application, a govern application. Okay, it's called Kudu or site control manager. Okay, it's something under the hood. We have not so much time to dig into the details, but inside the list of the web job we have this log. So think about a huge list of jobs here, and each one with its logs, and especially for triggered ones, For instance, a job that should execute every 5 minutes, every execution, so every 5 minutes is a single execution, and every execution is a single log. So it's very, very powerful. And we run our console application workload without any lock-in, without any hassle, without anything. Good. And to resemble this, to recap this, I want to say that Batch can scale a lot, and we can choose our VM size. In app services, not so. So we have just 3 sizes of VMs that runs the workload under the hood, and for a maximum of 30 or 50 machines. I don't remember, but it's not so scalable as Batch. Okay, but it's really easy in terms of management. The last service of the day is container services. Do you know Docker? Probably the answer is yes. And if you use Docker in production, you will probably have Kubernetes. Okay, so it's really easy for Azure customers or Google Cloud customers and the AWS customer, the cloud vendors customers to have K8s in production, because everyone has its own offer. In Azure, it's called Azure Kubernetes Services that runs a Kubernetes cluster without the complex details of managing resources. Okay, but if you don't want that, okay, and I'm one of them, okay, I really don't want a Kubernetes cluster to run my workloads, we can also run standalone Docker images with the good orchestrating techniques provided by Microsoft without having our own Kubernetes cluster. I would call it serverless containers, okay, because container instances is the way to run Docker in a serverless fashion, okay. And let's go and let's see this in production, in action. Okay, we have this. We have a Docker file. This Docker file, I would change it to Azure DLL. I'm placing into this path with the console. Okay. Okay, that's good. I also copy the Docker file inside this. It's not really what I would like to do in production, okay, but in production I have some pipelines that eventually create also the Docker file during the pipeline. So I really like that approach. So I place the Docker file here and I create the Docker image. So Docker build. But I want a tag, and the tag is based on also on the container registry that I want to publish my image to. So let's go back to Azure. Let's create a container registry. That is the place where containers, the image, are pushed to be used by services. Let's create this. Azure Day. Now, okay. Container registry. Okay, this is good. Let's go ahead. This is really cheap. This is really fast. This is really useful. Okay, so I created my Azure Day CR container registry. So here, before everything, I say Docker login to Azure Day CR.azurecr.io. Username is the name of the service, and the password is here. CR. Well. Again. CR. Okay, log it in. Now Docker build with the tag Azure Day cr.azurecr.io/demo, something that is on this path. The Docker daemon will read the Docker file will take the latest image from Microsoft, .NET, etc. That is an Ubuntu or Alpine image, I don't remember, with already the runtime, the .NET runtime installed. It copies the binaries and it writes the image locally. So now we can take this image and push it remotely. Push. Okay, it's being pushing. Okay, let's wait a few seconds, and here, okay, we have the container. Right now, we are near the finish line because with Azure Container Instances, we are just telling Azure to create a container that is called Azure Demo, based on the image that is taken from the container registry. I can choose the allocation of CPU and memory. Why? In this service that is serverless, I am billed by the seconds that the container is up and running. But if our workload is requesting more CPU or more memory, is not really ready yet to scale that memory and CPU automatically. So we need to place a cap, to place a reservation on this. You can see 2 cores and 4 GB of RAM and eventually a GPU. In case of a container that has a web endpoint or a TCP endpoint, we define these endpoints here. In our case, it's not needed. And this is the retry policy. So in case the container will fail, I want to restart it, yes. In case it's running, it's ending with success, I want to restart it, I don't know. In case yes, I would say always. Otherwise, I can say on failure. And if I don't want to restart it, never, I should choose never, okay? On failure, it's the better approach in my opinion. Why? We will see in a second. Think about there's some already created Kubernetes cluster under the hood. So I'm telling you this. I don't know this actually. I don't have the visibility on the underlying infrastructure. But since the container is running in seconds, okay, it's very likely that under the hood there's an orchestrator running somewhere. Okay, in Microsoft governed resources. So let's wait some second, but I think that this is already created in a running state. So if we go here, we can see the logs. Okay, the logs shipped, and we can also connect inside the container to, I don't know, because it's useless to connect inside the container, but if we want to perform some debugging, we can do this here, okay? After the container executes correctly, in this case 5 minutes, but we can also stop it right now, also the billing is stopped. So in case we run 10 seconds, we pay 10 seconds. In case we run an hour or a day, we pay just the time the containers is up and running. What I'm going to tell you with this, that Azure Container Instances is very good to all that workloads that can have, for instance, a great spike. I use this with in that moments of time in which we have like 10 millions of events to manage, to handle. So to consume faster the queue, I will put hundreds of ACIs. I don't know why it's failing. ACIs concurrently, okay? And after the job is completed, they stop and the billing stop. So it's a very good way to handle the burst, the spikes, the unexpected loads in your platform. For the expected loads, you can use something that is more predictable. So Azure App Service, that you have that instance, that capacity, and it's okay. Or a Kubernetes cluster that can scale, but you have those machines and you can scale so easier, so faster as in Azure Container Instance. So in this case, I stop. And that's all. in the sense that that's all that I want to show you today. So, as a takeaway, think about platform as a service and serverless as the present and future for application development. Think about this is in production. It's not something that is cool stuff, rocket science. It's something that millions of people are using today. Okay, so please take a look at that and use that. To focus on this session, I want to recap that batch is for workloads that you want to assign to a specific VM size or to a specific to a pool that is really huge, so thousands or hundreds of thousands of machines, even big machines. Okay. App service is one of the simplest service, so you can go up and running in seconds. Okay, without any hassle, but it's not so scalable as batch. And container instance is the promise of Azure, and we will probably have some evolution on this in the next month. That runs containers, so Docker containers in a serverless fashion. Also very useful for temporary workloads. So now I'm here to reply to your questions. And thanks again to the sponsor and to everyone that supported me as Alessio in this session. Okay, I see. Okay.
Hi, Roberto.
Hi, Alessio.
There is no question for you. I think your session is very clear. So.
Okay, perfect. Thank you very much. I'm here the same to get a question on the live Q&A, or you can follow up on this session or write me an email if you have some concerns or doubts about this. So thank you very much for being here, and let's see in the next event. Bye.
Thank you, Roberto. Bye.